Okay, this is question 1 of the Calc BC 2024 FRQs, and I'm not going to read out the question, I'm just going to jump straight in. So the first question, 1A, says approximate the C prime of 5 using the average rate of change of C over the interval 3 through 7. So for this question, there really isn't anything you have to solve. It's literally saying to approximate C prime of 5 using the average rate of change on the interval 3 through 7. So let's do that right now. So the average rate of change over the interval is really just the slope of the endpoints. So it's 69 minus 85 over 7 minus 3, which is negative 16 over 4, or negative 4. And now it's asking us, well, what are the units of this, what are the units of measure for this answer? So the original function C for the input T, it would output the temperature in degrees Celsius of the coffee cup, right? And then this would, for input T, C prime of T would output the rate of change of temperature of the coffee. Yeah, you'd output the rate of change. So it'd be negative 4 degrees Celsius over a minute. So at t equals 5, the function is decreasing at negative 4 degrees Celsius a minute. That's 1A. Right. So 1B, it says approximate it using the left Riemann sum with the 3 sub intervals. And it also says interpret the meaning of this. So let's do the part A of 1B. Let's just identify our intervals. It's 0 to 3, right? 3 through 7, and 7 to 12. And the distance between the intervals for x right here, right, is 3, 4, and then 5. So the left y value of our interval is 100 for this one. The left y value of this interval is 85. 4 times 85. The left y value of this interval is 69. So now, if we add up all these values, all these rectangles, we should get, okay, so the first one is 300 plus 4 times 85 plus 5 times 69. You should get 985 is your answer. Then it doesn't say to include units of measure, so don't include units of measure because you probably get it wrong. Actually, no, you wouldn't get it wrong. So it says interpret the meaning of 1/12 of the integral 0 to 12 of C of t. So if you didn't know, the average value on a function is the average value on an interval for some function is 1 over b minus a integration a to b of f of x dx. So this right here is in the form of this. So really the answer is the given expression represents average value. It represents the average temperature of the coffee from t equals 0 to t equals 12. Okay, so that's 1B. Now we have to do 1C. Now it says from 12 through 20, the rate of change of temperature of the coffee is modeled by this function. And then it says find the temperature at t equals 20. Okay, so a common mistake on this problem that I foresee is, the person will just say, they'll see t equals 20, they'll say this function, they'll integrate this function from 0 to 20, right? And then they'll try to solve it. Or they'll just integrate this from 12 through 20 and then interpret this as their answer. If you integrate from 0 to 20, this is undefined, so that should tell you something is wrong. And if you read the problem closely, it says this is only for 12 through 20, but it's asking for t equals 20. And for t equals 20, it's from t equals 0 to t equals 12, and it's from t equals 12 to t equals 20. So what is it called? The temperature of the coffee from 0 to 12 is 55 degrees Celsius, right? And then the temperature of the coffee from 12 through 20 is the integration of this function from 12 through 20, since this is the rate of change. So the integration of the rate of change is just the actual thing that's changing, right? So it'd be 55 plus 12 to 20 of what, the function c prime of t dt. And then since you have access to a graphing calculator, you just plug it in. So no, not 55. So you just type an int 12 through 20 of negative 24.55 e to the 0.01 t, right, over t dt. And the answer for this is like negative 14.671. So it'd be 55 minus 14.671, which we can also solve this here. The answer is around 40.329 degrees Celsius at t equals 20. Okay, that's 1c. Now 1d, I'm going to do it over here. It says the second derivative of c is this function right here, and it says for the interval 12 through 20, determine whether the temperature of the coffee is changing at a decreasing rate or an increasing rate. Okay, so determine whether the temperature of the coffee is changing. So what it's asking here is the change, okay, I'll just write it out. Is the change in temperature of the coffee, okay, temperature of the coffee changing at an increasing rate or a decreasing rate? So the change in temperature of the coffee is referring to this first function. And as we know, if the derivative of a function is greater than 0, the function is increasing. And then if the derivative of a function is less than 0, the function is decreasing. So the derivative of this function is this right here. So if we plug in any number 12 or any number on this interval 12 through 20, this always has to be greater than 0, because if I plug in 12 right here, this is just 12 squared, right? And this is always going to be positive. 20, this is just always going to be positive. And then 100 minus 12 will always be positive. 100 minus 20 always be positive. So for any number on this interval, if I plug it into this function, it will always be greater than 0. So what that tells us is the temperature of the coffee is changing at an increasing rate because c double prime of t is greater than 0 for any number on the interval t equals 12 to t equals 20. And that's the question right here.